hi to Paisley and Avila. Say hi, Paisley and Avila.
There's no way Paisley's watching this right now. They're not watching it live.
Yeah, they're not watching it live. We talked about that yesterday. It's asynchronous.
Hi, guys.
Good job. They miss you, kind of. All right, and let's get started then. What questions did you have that you wanted to go over?
1 second.
1 second. Oh, we'll hit pause.
Number 2, not 2, 3.
All right, what's it say?
Express negative. Okay. The square root of negative 81 in terms of I.
Okay, so the very first thing we have to do is take care of the negative. So that's the square root of 81, I. And now we can reduce the square root of 81. The square root of 81 is 9, so that's 9i.
That's it.
That's it.
That's the whole, what am I saying? Don't do that.
All right, any other questions before we move on?
Okay.
All right. So moving on. So we learned yesterday, just a quick recap. On last week's episode. We had
Last week or something.
I
Yesterday.
to the 0 is 1. I to the first power is I. I squared is negative 1. I cubed is negative I. And I to the 4th is 1, and it repeats the pattern. I. Can, da-da. All right. And then we learned yesterday that you add and subtract complex numbers. If I have two complex numbers, if I'm adding or subtracting them, I add the real parts together, and then I add the real parts together, like that. And you just add the I parts, and then you add the real parts. You just collect like terms, adding and subtracting. So today, we're going to learn how to multiply and divide. Yeah, and then we'll have all the basic functions down. So that's what we're going to do. Work on multiplying and dividing. Right? So, multiplying. Let's say I have multiplying complex numbers. I find this all very relaxing because it was really just algebra 1. It's just foiling. That's it. But there shouldn't have been. I thought I withdrew that, all of them. I don't know. There should have all been, oh, it was their squared one. There shouldn't have been, but I had thought initially that I would get all the way through the 4 operations, add, subtract, multiply, and divide yesterday, but we didn't. So now we're doing it now. All right, so we have 3 plus 2i, and I'm going to multiply that by 4 minus 6i. And we're going to see where that takes us. So I FOIL. First, 12. And minus 18i plus 8i minus 12i squared. Now the cool thing about complex numbers is they end up what is called a closed field. If you multiply two things of the form a plus bi together, you end up with something of the form a plus bi. Like that I squared, you'll never get a quadratic or a cubic because they can always be reduced to i's, right? So this becomes 12 minus 10i minus 12i squared. But I squared, my friends, is negative 1. So this is 12 minus 10i minus 12 times negative 1. which is 12 minus 10i plus 12, which is 12 plus 12 is 24 minus 10i. And that's where you end up. Any questions on that? That's multiplying. All right, so if I want to square something, say 2 plus 4i squared. Okay. You would square it just like you would square a binomial. 2 plus 4i times 2 plus 4i. And FOIL it out. But we know what the form of a perfect binomial of a perfect square is. It's the first thing squared plus 2 times the first times the second thing plus the last thing squared. All right. So this is 4 plus 16i plus 16i squared. But I squared is negative 1. So this is 4 plus 16i minus 16, which is negative 12 plus 16i. Keep in mind, you're always going to put your non-I term first and your imaginary term second. Any questions on that?
Would it be considered wrong if you put your I term first?
It would. I mean, technically it's not wrong. They're the same number. But technically these two things are the same number too. So they're just, you know. All right. Now let's try dividing. Before we get to dividing, we have to have another tool in our toolbox.
Not more toolboxes, Brad. Just 4 uses toolboxes too.
This particular tool is called the conjugate.
Oh, I know that.
Okay. All right, so the conjugate, if you have a plus bi, is a minus bi. So your real part keeps the same parity, the same sign, but your imaginary part changes. Okay? And the imaginary part is the part that has to change. So if this was written in the wrong order, and the I came first, then you have to change the first thing instead of the second thing. You know, like you have to make sure it's written in the right order before you take the conjugate. But the big thing is you're changing the imaginary part, keeping the same parity of the real part. Okay. And this is the complex conjugate. Okay. So what happens when you multiply two complex conjugates together? If I have a plus bi times a minus bi, now I FOIL them out, I get a squared minus abi plus abi minus bi squared. So the middle terms cancel out, which is why we wanted them to be conjugates. And we have a squared minus bi squared. And I squared is the same as negative 1. So this becomes, should be b squared, I squared, sorry. Drop that. There's two b's there. Negative 1, so this is a squared plus b squared. Take the first thing plus the second thing squared. Boom, you get it. So if you multiply two things as conjugates together, you end up with just a real number, no I. You get rid of the I, and that is the key, is to get rid of the I. So let's do an example. If I take 3 minus 2i, what is my conjugate? 3 plus 2i. I will work it out. So the short way would say, take the first thing squared, 3, it's 9, and add it to the last thing squared. Right? But we'll go the long way and FOIL it out just to make sure that we did it correctly. 9 plus 6i minus 6i minus 4i squared. Cancel, cancel. 9 minus 4i squared. 9 minus 4 times negative 1. 9 plus 4, 13. Short way, because we proved it. Long way, just using FOIL. When in doubt, FOIL it out. Any questions on that? So now we come to division. Division is really just an application of multiplication over again. So here we go. I'm going to divide 2 plus 3i by 4 minus 5i. There we go. All right. Now I want to divide this, but there's no nice way to do this. So what we end up doing is we multiply the top and the bottom of this fraction by the conjugate of the bottom. So 4 minus 5i times 4 minus 5i. Should be 4 plus 5i conjugate. You have to change the sign. Correct you are. All right, now, top 8 plus 12i plus 10i plus 15i squared. And 4 pieces from the top. 8 plus 12i plus 10i plus 15i squared. The bottom, the first thing squared, these are just conjugates together, so I can take my shortcut. The first thing squared
16.
plus the last thing squared. This is real numbers. So I squared is negative 1. So this is 8 minus 15, which is negative 7, plus 22i. And on the bottom, I have 41. So my answer is a real part plus an imaginary part, a plus bi. Okay? So I will write down the steps for you for dividing complex numbers. All right. Step 1, multiply top and bottom by conjugate. In this case, it's d minus, or c minus di. FOIL out the top. Bottom is c squared plus d squared. Rewrite in new form. Something plus something I. Okay, and that's it. You just FOIL out the top, FOIL out the bottom, and then rewrite it in fractional form. Feeling pretty good about that? Do one more example, and then I will reach your homework, and you guys will have 20 minutes to do it here in class. Because it's just this stuff, you know. All right, so let's do 2 plus 6i minus 1 plus 4i. All right, so what's my first step going to be, Morgan?
You're going to get the conjugate.
1 minus 4i. Multiply the conjugate by the top and bottom. FOIL out the top. Should be 4 pieces. 2 minus 8i plus 6i minus 24i squared. Bottom, 1 plus 16. All right, top becomes, becomes a go away, change the sign. 26 minus 2i all over 17. 26 over 17 minus 2, 17i. All right, and that's it. None of us wish we were on a hot, sunny beach or in warm Vegas watching rodeos. We're all really, really happy to be right here doing pre-calc, expanding our minds, conquering the world.
Couldn't be more happier.
Couldn't be happier. Too bad you guys are losers and aren't here. Bye.